If ever we needed more proof that yesterday's conventional wisdom is today's grim reality, the Cessna Skycatcher may be Exhibit A. The Skycatcher was destined to sweep its way to the top of the light sport aircraft market, mowing down most of the competition in a relentless drive to market dominance. In a move that stunned reporters at the NBAA show in Las Vegas in 2013, Cessna CEO Ernest abruptly announced that the Skycatcher program had no future, and with some 200-plus aircraft in the field, dealers and Cessna pilot centers have been told nothing to suggest Cessna doesn't mean what Ernest said. To understand how a program with so much promise went belly up so quickly, we need to go back to why Cessna built it in the first place. Cessna went after the Skycatcher because their legacy two-seat trainers, the 150s and 152s, were aging out of the system. The average 150 or 152 on a school's ramp was already several decades old, and operators were dealing with rising maintenance and overhaul costs on airframes that had long passed their design lifespans. Schools were relying on increasingly scarce parts and repeated engine overhauls just to keep those airplanes flying. At the same time, the light sport aircraft category had opened a path to build a simpler, cheaper design without taking on full Part 23 certification. New LSA manufacturers were already stepping into that space and supplying brand new trainers to schools that historically would have bought Cessnas, and Cessna knew they were at risk of losing first contact with new pilots to those European and composite LSAs. Those pressures made the Skycatcher Cessna's attempt to claw back control of the entry-level training market before it slipped away. So Cessna hoped the Skycatcher would let them replace those aging 150 and 152 fleets with a new production Cessna product. They wanted a trainer that burned far less fuel than a 172, somewhere around 5 gallons an hour, which would immediately cut operating costs for small schools. They also wanted to hit a purchase price low enough that small schools and flying clubs could justify buying new aircraft instead of rebuilding old ones yet again. The whole point was to provide a simpler, lighter, less complex solution than going through the cost of certifying a new two-seat trainer under Part 23. Cessna wanted to reestablish themselves as the default basic trainer supplier in the U.S. and worldwide, with enough demand to create a true high-volume piston line that would keep Wichita busy. The Skycatcher was supposed to be the gateway aircraft, start students in the C-162, then move them into the 172, the 182, and the rest of the Cessna family as they advanced. The market segment they were targeting was primary ab initio training, first hours, first solo, pattern work, and basic maneuvers. It was also aimed squarely at light sport pilot training under U.S. sport pilot rules. Beyond that, they expected it to appeal to entry-level private owners who wanted low operating costs but still preferred a well-known brand. Flying clubs and university programs that wanted standardized, modern two-seat trainers were another core target. And they saw it fitting well in schools operating in flat, low to moderate elevation environments where modest power and typical LSA performance were fully adequate. Taken together, that strategy made perfect sense on paper. In the real world, almost every key decision went the wrong way. Cessna announced the airplane at AirVenture 2007 with a price around $109,500, and the order counter on the booth went wild. Hundreds of positions by the end of the week, and over 1,000 a year later. Then they announced it would be built in China by Shenyang, with engines shipped from the U.S. to China for installation, and completed airframes shipped back to Wichita for final work. That decision triggered immediate blowback in the U.S. market on both jobs and perception, and it didn't deliver the cost savings they needed. Textron wanted the program to be profitable, and the $100,000 class entry price turned out to be fantasy. As redesigns and production snags stacked up, the price crept up, then jumped hard. By 2011, the Skycatcher was sitting around $149,000, which put it in the same economic space as a decent used 172 or a higher-spec competitor LSA. When Cessna let position holders bail out after the price hike, hundreds did. Development flight test made things worse. Cessna lost 2 Skycatcher prototypes in spin testing. One entered a spin, failed to recover the way the engineers expected, and went under the parachute. Another was also lost in a spin-related event. For a primary trainer, you don't get more damaging news than, "We lost a couple in spins." To keep the program alive, Cessna had to change the tail, add more vertical area and a ventral fin, and adjust the envelope. That cost time and money, pushed deliveries back to 2010 and beyond, and left the production aircraft with handling and performance that did not line up with the early marketing numbers. The accidents also set the tone. Instructors, insurers, and operators now saw the airplane as having a question mark right where they wanted the most confidence. When the Skycatcher finally entered service, its light sport aircraft weight limits and cost cutting showed up everywhere. It had to make the 1,320-pound light sport aircraft maximum gross weight, and the standard empty weight sat at about 834 pounds, giving a useful load of about 486 pounds, or roughly 342 pounds of payload with full fuel. That looked workable until you accounted for the fact that the standard empty weight figure did not include items pilots treat as standard: a fire extinguisher, an emergency locator transmitter, wheel pants, primer, unusable fuel, and other bits. In real use, 2 full-size adults, full fuel, and those items pushed straight into the margins. Schools in hotter regions found that with 2 aboard and high-density altitude, climb performance was marginal for what they expected from a Cessna. The light wing loading that looked great on paper made the airplane a handful in gusty, bumpy air. Instructors reported that afternoon convective bumps and crosswind days were where the Skycatcher stopped being fun and started being work. The physical airplane carried a long list of usability compromises. Early in the fleet, many door latches failed, and gull-wing doors popped open in flight. On most Cessnas, a forward-hinged door will crack an inch or two and just make noise. On the Skycatcher, the upward-opening doors could catch the slipstream, blow fully open, and get damaged, which is not something a school wants to see on a student detail. Inside, the interior was stripped bare to save weight. There was no real heat or sound insulation, and any power setting below max cruise left the cabin cold. Use carb heat and you steal even more cabin warmth, so winter pattern work in colder climates could literally be a chilly experience. The Skycatcher didn't redeem itself in heat either. Neither side window opens, and the only airflow is through the wing root vents, so the cabin cooked on the ground in summer. The control and system setup added its own quirks. The airplane had no manual trim, only electric trim on the sticks, with trim position displayed on the G300 PFD instead of a physical indicator. All primary flight instruments lived in that G300. In the event of a total electrical failure, the pilot could be left landing without an instrument-based airspeed reference. For an ab initio trainer, that's a design choice many CFIs did not like. Weight-saving measures like manual flaps on a bar between the seats and a free-castering nose wheel that required differential braking for taxi made it feel less like a robust Cessna trainer and more like a dressed-up ultralight. On the runway and in the flare, the airplane had less tail clearance than a 150 or 152, so full stall landings in gusts brought a real risk of tail strikes. It was an airplane that demanded disciplined speeds, a flatter approach, and a very controlled flare. It did not tolerate the sloppy technique that older Cessnas quietly absorb while a student learns. Meanwhile, the wider LSA story was not doing Cessna any favors. The sport pilot and LSA rules did not trigger the expected wave of brand new young pilots. Instead, LSAs ended up largely serving older pilots who wanted to keep flying without a medical. Light sport machines, including the Skycatcher, imposed strict weight and performance limits that cut into the freedom narrative Cessna's marketing leaned on. That is not inherently bad, but it does not drive big training fleets in the U.S. the way a 152 or 172 did. Support and ownership economics eroded as well. Cessna built on the order of 275 Skycatchers, delivered a bit over 200, and left dozens unassembled. That tiny fleet size meant no big owner community, no dense ecosystem of used parts, and no surplus stream. Owners reported that airframe parts were expensive and hard to find. Skycatcher owners themselves warned that the cost and rarity of replacement parts were the main ownership concern. Schools looking at fleet lifecycle costs saw a small, fragile supply chain and backed away. All the while, competition and inertia were working against the type. Tecnam, Flight Design, eVector, and others already had LSAs flying with decent useful loads, friendlier cabins, and proven handling. Many U.S. schools simply doubled down on what they knew, rebuilding 152s and buying more 172s because the capital outlay and fleet risk were lower. They already had maintenance, spares, and instructor familiarity tied to the 172 platform and saw no reason to add a separate, more limited type for a small theoretical saving. Add the macro picture on top. The 2008-2009 financial crisis cut demand for training and made financing harder for both schools and students. Everyone became more conservative about adding new types. Inside Cessna, piston and light airplane programs were under review. The Skycatcher wasn't moving in the volumes Textron needed and carried a damaged brand, tight margins, and a long list of compromises. By the time Ernest stood up at NBAA in Las Vegas in 2013 and said the program had no future, the writing was already on the wall. Cessna stopped taking new orders, pushed remaining airframes out through the dealer network, and the airplane never reached the fleet size or training dominance that had been forecast. From the cockpit view, the Skycatcher failed because it tried to be a cheap modern Cessna trainer but ended up as an expensive, constrained LSA that didn't really suit students, didn't really suit schools, and didn't really deliver the economics Cessna had promised. In the spec book, the Skycatcher also sat in a bad place relative to what else was on the ramp. On paper, it offered about 118 knots at the top end, burning roughly 5 to 6 gallons an hour from a 100-horsepower Continental O-200D, but with only about 342 pounds of real payload left after full fuel at the 1,320-pound LSA gross. By comparison, a Flight Design CTLS worked with the same 1,320-pound limit, but typically carried around 550 pounds of useful load, cruised near 115 knots, and still burned about 5 gallons an hour from a Rotax 912, giving schools a lot more flexibility in how they loaded people and fuel. Tecnam's P2002 P92 family played in the same sport pilot space with a 100-horsepower Rotax, around 120 knots max cruise, fuel flows on the order of 4.5 gallons an hour, and useful loads in the 520 to 530 pound range at a slightly higher maximum takeoff weight. eVector's Sportstar, one of the earliest and more visible LSAs in U.S. schools, offered roughly 520 to 640 pounds of useful load depending on configuration, cruise speeds around 110 to 115 knots, and similar 5-gallon-an-hour fuel burns. Side by side, the Skycatcher didn't bring more payload, more endurance, or lower fuel burn than these established LSAs. It mainly brought the Cessna badge and a tighter weight margin. When schools compared it to non-LSA trainers, the value case got even harder. A typical Cessna 172N gives you about 599 pounds of payload after full fuel, cruises around 120 to 122 knots, and burns roughly 8 gallons an hour at 75% power, but does that with 4 seats and the crosswind and density altitude headroom operators already know how to use. A Diamond DA20C1 sits in the same 2-seat training niche, but offers around 580 to 600 pounds of useful load, cruise in the 125 to 130 knot bracket, and about 5 to 5.5 gallons an hour in a fully certified Part 23 airframe that many schools had already adopted as a primary trainer. Meanwhile, legacy 150s and 152s kept chugging along at roughly 5 to 6 gallons an hour and very low capital cost, which is why they remained the default cheap trainer in a lot of U.S. fleets. So when a Skycatcher showed up priced in the same ballpark as a decent used 172 or a well-equipped DA20, but with only 2 seats, tight payload, and LSA weather limitations, The numbers on the page pushed most flight schools toward the alternatives they already trusted. So that's it for today's video. Don't forget to subscribe and ring that notification bell. It helps me a lot.